So my name is Norman Judah. I work with David Vaskovich, who's one of our two CTOs. We have two CTOs, I guess, because we can. And he reports into Bill. And David and I are responsible for platform and technology strategy, which is really trying to look out 5 and 10 years away and really try and get a good understanding of where we should be going. Developing enterprise software is very hard. And as you guys know within your own organizations, it takes time both to plan and execute. And so if you think about us, if we believe that there's going to be a software discontinuity in 8 to 10 years' time, the 2012, 2013, that seems like it's a long way out. But in our methodology, in order to have software ready for that discontinuity, we want our second version available in that time at least. It takes 2 years to develop the second version, so that brings us back to 7 years from now. It takes us 3 years to develop the first version. That takes us to 5 years from now. And then we've got a whole bunch of planning. And it turns out that in order to meet that 10-year discontinuity, we've got about 18 to 24 months to do that planning now. That's the cycles that are involved in doing this kind of development. And that's the time frames that we're interested in. This deck that we've got today is actually trying to paint a roadmap over the next 5 to 6 years. We're not going to go beyond that, but it'll paint this roadmap. In your handout, there are some mismatches of slides. I've taken some slides out. I've put some slides in. I've changed some order. But the handout you've got is pretty much complete. And it's very long. I know that. And there's a lot of content over here. I'm not going to cover all that content. We left those slides in because I think it's important that that information is available to you there as a reference to know exactly which widget is going to be available in which wave of products. But I'm going to cover things that I believe are interesting to you guys and areas that I think we're doing some interesting work in. And so I won't cover all the slides. The slides are in my deck and your deck, and so please go back and use them for reference. And we'll sort of monitor it from a timing perspective. And so the first thing, I was asked to talk about a roadmap. And so what's a roadmap? Well, there's kind of a roadmap. This is from MapPoint. It has very good maps if you've been there. But it's kind of static. That's the problem with roadmaps, is they're pieces of paper. Even if they're software, you have to update them to change them. Many of you have, I'm sure, GPSs in your car and to tell you where to turn and where not to turn. But periodically you need to subscribe to a service that sends you a new CD or DVD so that you can get the new maps. And areas do change. And that's one of the problems about a roadmap or a book or even in software, is that they have a very short half-life in many cases. And so, from Microsoft's perspective, we want to paint some kind of map, but I'm not sure that we want to paint a roadmap. The thing that we're much more interested in is a wave map, because we release products in waves. And it's the core of the wave and the other parts around the wave that are more interesting to us. So, in fact, we shouldn't be talking about a roadmap, we should be talking about a meteorological chart of pressures and winds and temperatures that start to describe the dynamics of the marketplace that we're in, and how that then leads to the product waves that we have. And so the question is, where are we today and where are we going? What's next? What is the next wave that we're going to go into? We've had this history, but where are we headed today? And so through this agenda, I'll spend probably the first half of the session trying to describe the environment of where we are, the driving forces that we see happening, the industry initiatives, what we see customer initiatives, as well as some of the predictive work that we're trying to do to predict out what software is going to look like in the 5 and 10 year window. To try and think about that, go back 10 years from now. So go back into the year 1993 and think about what we all were thinking about in software at that point and where we are today. The Windows 95 was just being talked about at that point. 32-bit applications were just a discussion point in this area. Servers were an interesting challenge at that time. And so when you think about where we are today and sort of how wrong we were, it's very hard to predict that time out. In fact, typically, we're very aggressive about short-term predictions. We predict too much in the short term and too little in the long term. And in the long term, we're actually more successful as an industry rather than we are in the 1 or 2 year time frame. And so I spent the first half talking about that environment, and then the second half getting into some of the individual details of some of the interesting initiatives. Having been an architect, I've been at Microsoft about 14 years, and prior to that I worked for Exxon for about 12 years, and I was an architect there. Typical architecture presentation. You walk into an organization, a priorities committee with an architectural project, and you draw a picture that looks like this. I've seen many pictures like this. I'm sure you have your own. That actually shows a whole series of spaghetti, and you make a speech to this planning board about please give us lots of money because our systems today look like this. There's multiple systems, multiple databases, data is replicated all over the place. They're all interconnected in strange ways. And if you invest $10 million or fill in the blank in your amount in me and our architectural project, we'll have beauty. We'll have perpendicular lines. We'll have a single message bus, an agreed-to data model. All systems will share things. We'll have a common directory. Everybody agrees with the planning committee. They say our IT costs are way too high. We have to bring them down. They give you the money. And then interestingly enough, you come back, 8 or 10 years later and you say, we used to have this glorious thing, but we now added all these other systems. We did some acquisitions. We divested part of the company. We're back at this mess again. I need another 10 million to be able to rationalize again. Why do we get here? I mean, this is actually reality. I've lived through this, and I'm sure you have. But the question is, why do we get there? And why do architectural projects occur or reoccur? And the issue that we start to deal with as a community, as an architectural community, is what are the elements of the things that we work in that have a durable half-life? What are the things that last longer than others? For a while, we were betting on data model. Everybody did an enterprise data model and then started to build enterprise systems around the model. And then many companies went off and bought SAP and said, here's our model. Because that turns out to be the easiest organizational way of implementing a unified model. Because I'm sure many of you got involved in developing enterprise models and got into the organizational issues of having the wholesale organization and the retail organization try to agree on what a customer was, and they could never get there. And so these modeling exercises went on forever. And so there really is an interesting challenge of thinking back into what are the durable elements of the architecture, whether it is at the low-level technology, if it is in the designs, if it is in the various semantic models that we've got, is it in the organizational model of the company, in the personality of the people in the company? What is it the things that start to dictate the shape of the work that we do, and where should we be investing? We've done a lot of work in this area, not part of this presentation, that sort of starts to propose a domain which says it is the business processes in an organization that are unstable, but the individual things that people do, the other things that are stable. I accept purchase orders. I send out invoices. I always do that, no matter what my real business model is. And so we've tried to go in and define the sort of low-level business services and how that matches into the stability of the company. There are areas like security where we all have a huge problem in trying to find a stable base on which to build a security infrastructure. And so in that view, you start to get some technology domains that drive in some directions, but you've got this conflict between the business view and the technology view about where the stable points are. And more complicated in an interesting way is who owns those various aspects organizationally? Who starts to make the decisions? Because unfortunately, it has been the IT department that has been driving this architectural view. And I believe that the business needs to get actively involved in starting to define the way our architectures live, and it needs to be both bottoms up and tops down. And so in the light of that, what is the role of a technology roadmap? Is it important? Is it not important? Which parts of the roadmap are you interested in? And so what the story that I'd like to paint today then is to really try and explain to you where we're investing. Because where we're investing is where you will see products being delivered from us. The aggregation of technologies into products may be different than the way we actually describe it today, but it's where we're putting people and where people are working on our technologies that will give you the insight into where that is happening. The dilemma that we face today, both in terms of business as well as in technology, is there's an imbalance. There's an imbalance between the things we're being asked to do and the things that we can do. The requested competencies, as we call them, versus this available competency. And how do we deal with that gap? In a business sense, that's generally dealt with in outsourcing. We take a call center and outsource it to India. Or we take logistics and outsource that to UPS. But in a technology view, how do we start to fill that gap between the demands that are being placed on us and our ability to react? And so again, this is one of the important parts of the sort of wave map view, We can paint the picture of what's inside of that question mark triangle, inside of that space. You guys can then start to think about how you fill the gaps between what is available from a technology perspective, from us and other companies, from all of your suppliers, against the demands that are being placed on you, A, by the business in which you operate, but more interestingly, as businesses change today, by the partners that you deal with. The typical scenario, the interesting little scenario is I'm a small grocery manufacturer, and I'm being very successful, I have an interesting brand, and I start to sell to the big retail chains. I start to sell to Costco, to Walmart, and to Target, let's say. Each one of those three big companies has a different way of doing business. And they're not terribly interested about whether I want one way or three ways. Each one of them is interested, if you want to get your stuff on the shelf in Walmart, this is the way you interact with me, Costco and Target, each one, and they're completely different. The base data and the documents that move around are similar, but the way the interactions occur are very different. And so as this small, grocery product manufacturer, how do I live? And I'm in fact caught in this incredible dilemma about not being able to talk to all these people, but from a systems perspective, they want to buy my product and I'd like to sell my product. And so this imbalance is actually derived in many cases not only from the technology, but from the business side. And so we need to start talking about waves of innovation in the way that we've seen them. And we've talked about these three basic waves that have been going on, but there's an interesting aspect to this slide. There are these two waves that are about 180 degrees out of frequency with one another if you look at them as sinusoids. The first part, the blue wave, is around development. That's when we have an idea and we go out and do the hard engineering about building it, testing it, finding out what you guys want, what partners want, what ISVs want, what customers want, and start to build that. And it's the conversion of an idea into intellectual property. But there's a lag. There's an interesting lag that occurs behind that, which is this adoption curve, the orange curve in this picture, which is the conversion of intellectual property into the actual customer benefit. There's some great work that Business Week magazine did on these various adoption rates for technologies. The fastest adoption rate used to be DVD players. It's now cell phones of a particular kind. And the adoption rate of technology is shortening dramatically. They've gone back and done this analysis from the invention of electricity to the sort of broad adoption, motor cars to the broad adoption and so on. And so we're going into a mode now where the adoption curve is getting much closer to the development curve, and we're starting to see more and more of these interesting waves. If you think of the DVD player wave and the cell phone wave, those are very compressed compared to what VCRs were in the sort of time period that happened with VCR. And so the thing that we're interested in is obviously this next wave. What is the interesting things that are going to happen in that next wave? And how do they on this dilemma between the development of technologies and the adoption curve associated with it? And so the point that we're at today, and this is sort of the web services semantic area, is around the connectedness of enterprises. It's around the interactions not only of systems to systems, but people to programs and people to people, and the impact that web services and the web service architectures and service-oriented architectures are having in this mode. Two other interesting pieces that are starting to evolve in that work today is around information-driven applications and how we start to address content in interesting ways. And then the third part is around experiences, user experiences of different kinds. Because we're starting to get interesting changes of the hardware, we're starting to get interesting changes in the user experience, away from document-centric, forms-oriented, into much more interesting audio-visual, multi-dimensional views into data and applications. The first one that it's interesting just to see how quickly this has taken off is plasma panels in a 16 by 9 orientation. If you walk through just about any airport today, the displays that you see that have arrival and departure times invariably is some form of a plasma panel in a widescreen view. I was down a couple of weeks ago in Connecticut. I went to see a big financial house, and their operational desk was all plasma panels. It was all these big plasma panels because they can get more information into it in interesting ways onto those screens. The flip side of that are telephones and the way we're going with telephones, where the cameras inside of phones are going to start to challenge the little digital cameras that you carry around with you. The cameras in phones creates this incredible privacy issue where it's now very easy to take a photograph where previously in another world you'd have to take out your camera with a flash. Now you can surreptitiously take photographs. And so there's a very interesting privacy security issue attached to phones, and they're taking pictures attached to phones and then sending those pictures via email instantly to somewhere. And so we're starting to see this interesting mix occurring as technology and the hardware is ramping and some of the social impacts that it is having. One of the biggest changes is then obviously around web services. And most of the work that was done in the previous waves was around the abstraction of hardware, from our view. It was really around making it easy to do things and change things in the hardware. We should actually step back today and think a little bit. When you take a USB dongle and a drive and plug that into your computer and suddenly it gets recognized and you can transfer stuff over and you can unplug it, think about what that looked like 10 years ago. You know, it might have been an 8-inch floppy disk or a 5.25-inch floppy disk, and it was a fairly complicated task, where today, most new machines that you buy don't have a floppy disk in them. But the ability to actually plug a hard drive in and take it out is actually pretty astounding. And so the way device management is occurring and the rate of change in device management is actually astounding. From our perspective, that just means a huge amount of testing. There's a bunch of great technology, but being able to test every combination of video card, display driver, and every motherboard, this is a huge amount of work, and we have thousands of people who have to do that degree of testing around drivers and driver hardware. But that was a big part of some of the previous waves, was about the abstraction of hardware. That's changed dramatically. What web services have done is really taken that to a completely different level. And it's really about the abstraction of services. It's about the abstraction of both technology services like security, but more interestingly enough, in the area that I'm interested in is the abstraction of business services. It's the abstraction of my ability to accept a purchase order or my ability to send an invoice. And it's led us to actually allow companies to play in different ways, where they outsource different parts of their businesses or even integrate internally between divisions using this web services model. It's taking a long time for all of us to think about what the impact of service-oriented architectures are. Bottom up, the impact is really about technology and directories and securities and WSDL and XML. The impact is at the business level, about the business trying to understand what these services are. And to some degree, it's a business view that you're publishing out. And so from a technology perspective, although we come bottom up and say, here's the service to accept a purchase order, what's actually happening in a business view is the company's hanging out a shingle on the internet and said, I have purchase orders. And so what they're doing, the business is conceptualizing their model of their business that they want to publish. They're conceptualizing the way they want other people to think about them. And web services is simply the technology mechanism to allow that to happen. Part of what is happening here is what we're calling power to the edge. It's a view of the rate of change of technology and what's happening with that technology. There are various interesting laws, all of which seem to be continually true, about bigger, better, faster, smaller, and that USB drive problem, is actually a sort of a view of that. It's an encapsulation of how quickly things are changing. But the biggest impact that we're seeing from all of this interesting hardware change is that there's an inversion where we now have the ability to do interesting things from a performance and power and computing capability at the edge. Your phone is sitting at the edge, but it has incredibly interesting capabilities. Given the new smartphones that we have available, we're starting to see lots of very interesting enterprise applications being built on those smartphones. It's not just a phone that supports email and calendaring and alerting. It actually starts to get applications on it that can synchronize either in a synchronous or asynchronous fashion with another application sitting either at the edge of the network or at the center of the network. And so this change of hardware allows additional computing capability to occur in lots of different places. And the problem that we're dealing with is a heavily distributed computing environment. And how do you deal with the issues of synchronization of data, synchronization of security, or privacy? And there's a whole series of dimensions to that really changing the way we need to think about applications and the way that they're built. And so the fourth wave that we're in today, coming out of these others, is really around what we're calling seamless computing. And seamless computing derives essentially at the core from XML and ubiquitous communication and the fallouts that have come from there. That's sort of a snapshot of where we are today. Looking forward, there's some very interesting things that are happening in the home. Much as we see this power in the edge, we see the power happening at home, and this incredible rate of change of computing processing that's happening at home. A couple of weeks ago, I installed via Comcast cable, high-definition cable boxes at home. And the amount of processing that in there is actually quite astounding. The cable box has a FireWire port, a DVI port, 2 USB ports, an Ethernet port, and has the ability to process, to decode and process 1080i. It's incredible capability. The most interesting thing to me on this change of cable boxes was the cable boxes previously you had to have a phone jack close to the cable box. And it was that pain in the neck to run the phone cable. And that was so they could validate and provide a little bit of download. These new boxes, that's gone. The cable box actually has a DOCSIS modem built into it, and that actually just does an IP communication automatically back to the back end. It's actually quite amazing that rate of change that's happening in the home as well around the machines and who they are in your home and what they do. Interestingly enough, in my home in Seattle, I have radiant heat in the floor. It's heat tubing in the floor, and that heat tubing sits on a grid. It's on a metal grid that's 6 inches. And I have a double-story house. I have this metal grid on 2 floors, and I live inside a Faraday cage. And so wireless networking doesn't work inside of my house. And so in some view, we think about wireless networking as being the answer to lots of problems. It is. But we're still going to have to deal with wiring and wires and how they work. It's the same as the wireless network up in your rooms. It doesn't always work. And it's very important to actually think about this connectivity. And so it's not all going to be about the way technology is moving. I'm not going to spend a lot of time talking about the kinds of things that we're doing in media and in TV, but there are interesting technology fallouts that have happened where we see this multimedia aggregation of data and the use of voice and video and multimedia in applications that starts to take a lot of that stuff where we thought the user experience was at home and actually start to pull that into office applications. You see that in many cases, for example, with the real-time communication server that we have, and the ability to have multimedia conversations over some connected environment, either over private networks or over the internet, that starts to talk about when do I actually need to travel to have this meeting, or can I do it in an interesting, interactive way? As you probably know, we acquired some time ago Great Plains Software, which is based in Fargo, and they acquired another company called Navision based in Copenhagen. And it's an interesting problem when you've got development split across effectively 3 continents, but have it split. And how do you tie those meetings together? So this is actually a facility that we use in very interesting ways. I have been to Fargo at Christmas, and it's cold. We see some other interesting environments that are happening. We've done some pretty interesting process mapping around organizations and how they work. And this derived from some work we did about why is B2B failing? Why isn't B2B working? B2B is working in many cases for some organizations, but in most cases, it hasn't been working for people at the edge. And so we went back and did some process mapping about the purchase order life cycle and what happens. And what we found is that to your left, to the ERP system, if you look at the number of communications that are occurring in a typical order life cycle, the number of communications into the ERP system as opposed to the number of communications that the buyer participates in is about a 3 or 4 to 1. There's lots of communication that goes backwards and forwards about changing a purchase order, when is my order coming, I'd like to change the shipping date. All of those communications occur outside of the ERP system. And so one of the things that we're looking at is from a workflow perspective, or process flow is probably a better term to use here, is how do we start to integrate this complete process flow? How do we start to integrate not only the structured flow, but the unstructured flow into a single context? And what does that mean? The other part that we're adding into this is the participation of people in the process. Because most of B2B was about getting people out of the process. It was about saying we've got 2 beautifully constructed systems that can talk in beautifully constructed SML over HTTP, and they can all get together, but it doesn't work that way. For Walmart, it works that way because they insist on doing business that way. And for them, it's a highly profitable, effective way of doing it. But for many organizations, that doesn't work. The communications that occur are, in general, have people involved in them in some fashion. And if you go look through the audit department in many organizations, you'll find filing cabinets with binders and manila folders that contain audit history. And when you look at that, there's faxes, there's phone calls, there's notes, there's little yellow stickies. And so in this area, we think this is a huge opportunity around two aspects. Taking the workflow and actually allowing the workflow to cross these dimensions, and then secondly, being able to address people in the process. One of the interesting implications of this, and this is where all of the workflow products in the marketplace today fail, is that I have my workflow about submitting an order to you, and I go through my workflow and I send you an order. And I wait for a reply. I wait for an acknowledgement or a shipping notice or something. But what's happening is there's a process running on the other side. And the guy on the other side has his process engine, and he receives my inbound order, which kicks off some things. But those are really, it's one process. It's not two processes. As technology providers, we're failing because we have two separate products in place to do that. There's two separate instances of workflow. And so the first thing that we need to work on is that is one process. It just happens to have different states being driven in different organizations. But we then need to understand about how that workflow occurs in a unified way and how state changes on one side of the fence get reflected back on the other side of the fence. And so there's a bunch of work that we're doing on technology, but there's also some standards work that's required over here because you may not be running the same process engine on either side. And so we need to identify, for example, when you get a state change, how is that message notification sent back to me so that I can now update my state and take some action based on, you have a stock out, for example, and how do I see that? And so an extension of that, we see this very interesting business opportunity around business processes being unlocked between organizations across the value chain. Each one of the planes in this picture sort of shows an organizational and its capabilities. And then those projections are views to the way companies integrate across virtual value chains. And we see many, many organizations operating in this way today in interesting ways. And there's lots to learn for us all to learn in this place. In the technology industry is one of the leaders where you see the Taiwanese ODMs, you see Flextronics playing interesting roles within the structure. Flex is kind of interesting because Flextronics has two relationships with Microsoft. They sell keyboards and they manufacture keyboards and mice for us, and they manufacture the Xbox. And those are fundamentally different businesses. In the case of Xbox, we have a 20-minute visibility into their production line, and in the case of keyboards and mice, it's an inventory managed business. But on the other hand, Flex makes inkjet printers for HP, phones for some companies, routers for other companies, and they project out completely different views of who they are, yet underneath the covers, they're actually just a single company. And how can they do that mapping of their organizations? Is an interesting problem. And so one of the driving forces for us is this crisis of complexity that we've all got ourselves into. And one of the things that we've been trying to imagine has been, if we can take 15 points from your cost of your infrastructure today and move that into new capabilities, what would that do? And so this 30-70 split is based on a study that we did through Accenture looking at spending, and we're really trying to think about, can we bring down the 70 to 55? How do we have to do that? What are the fundamental things that we have to do that? Which, by the way, implies fundamental things that you guys have to do differently in thinking about the way you operate on your systems. And then how do we use that new 15-point margin? You guys have seen this data as well. This is a fairly recent study that we've done through IDC. It's a study that we commissioned, which says that the real cost of running systems is in the people that manage, maintain, operate, change, customize, get called out on Sunday mornings, come manage and organize those systems. And so we're very, very focused at dealing with downtime and then the staffing and really trying to get rid of that complexity and start to make things simpler along the way and start to make them automatable along the way. And so that we're dealing with exceptions rather than trying to deal with the sort of fundamental problems that many of us face today. And to start to address that, I believe that it's interesting you understand the bets that we're making. And so we're going to talk about the bets, and everything comes in threes for some interesting reason. I'm not sure what it is. And so these are three big bets that we're placing today. And the big bet for us means we spend money and people. As I'm sure you know, we spend, I think this year it's about $7 billion on R&D. It's a huge amount of money with lots and lots of people doing R&D, both from the sort of Microsoft research environment through product development. But the question is, how do we start to allocate those funds? And generally we try and bet on waves. And in this case, these are three interesting big bets that we're placing today. The first one is about connected, not just connected networks, but connected application networks. In order to do that and take advantage of a lot of the work that's going on around XML, we have a huge project, started off as an incubation about 5 years ago called Indigo, that's about a new way of messaging, a new way of creating a messaging infrastructure to deal with reliable messaging, redacted messaging, process flow on top of that. You started to see some bits for that if you've been to the PDC. You'll continue to see bits through Longhorn, and Longhorn will be the sort of first integrated place that product, that set of technologies becomes available. We spent a lot of time with the work that we've done on Indigo working on interoperability and integration, and have spent a huge number of hours working with various standards groups and industry groups trying to make that happen. So we have agreed to adoption of these various standards, and that work still goes on. It's been very aggressive over time, and has been very successful to have a series of technology companies from around the world focusing on what these standards are. Little tagline there at the bottom about Avalon, which is a new presentation bet that we're making. I have much more data on that further on. A lot of work around information and how we deal with information, and this is an area that we've tussled with for years. I'm sure there are some of you who remember a project called Cairo that was around an object-oriented file system that we were working on. And I believe that at the time we were just ahead of what was capable from a technology perspective, from a hardware perspective, to make that happen. We're really tackling that problem again about trying to manage information in a more interesting way where you can navigate, query, aggregate, and act on information that's kept in the various systems that we have. The team that's done the fascinating research on this is the Office team, particularly in Excel. The Excel guys go out and they actually will ask you if they can see the spreadsheets that you've got in storage and what's in them. And it turns out that Excel is the accounting system of choice for many companies. It's the database system of choice. It's the list management system of choice. It's the football pool of choice. You know, it does everything for everybody. It's amazing what people do inside of Excel. But the place where Excel fails today, Excel does nothing to help you in any of those environments. Excel just manages lists and draw graphs and have multidimensional cubes and pivot tables, but it knows nothing about the information that you've got. You've started to see an inkling of this where if you fill a cell with the words January and February and then drag them down, it says, this looks like a bunch of months. After February, I'm going to fill in March, April, May. Or if you put in the numbers 1 and 2 and drag that, you'll get 3, 4, 5, and 6. And if you put in weeks, it's pretty interesting when it starts to learn a little bit about the data. And what that's about is about Excel getting schema. It's about Excel or Office starting to understand schema. And so one of the ways to think about our acquisitions around and our investments in the business solutions area between Great Plains and Navision, etc., was for Microsoft to get a core competency in schema, to actually start to understand schema. Because many of our products are actually empty. They come schema-free. They're content-free today. And we realize that that's changing dramatically and that we need to start to have an opinion on schema to start to make those tools and those products and technologies more useful to you. What that's leading to is the schematization of storage and a deep understanding of storage. It turns out we do have some opinions about schema. Outlook, in many cases, is the expression of context in most organizations. And so we have an opinion about contact and contact information that you guys actually see a snippet of, but Outlook in its availability around the world in, 37 languages has to deal with phone numbers, for example, in every possible format. It has to deal with address codes and zip codes that are not just numbers, but are mixtures of numbers and letters. And so the Outlook team has done a huge amount of work on the schematization of contact information, address, phone numbers, email addresses, and so on. Huge area of investment. And then the other area is thinking about if we do have power at the edge of the network, if we do have the ubiquitization of CPUs and memory and communications at the edge. What does that mean about the work that we can do to make it interesting to develop applications with business value sort of in that context? We're also making investments in what we're calling 3 fundamental areas. Fundamentals is really this sort of base level stuff that we're doing. The first one is in trustworthiness, and it's trustworthiness around the technology. I'm not going to talk about the sort of the company edge of that, but the trustworthiness around the technology that we produce, the reliability of the technology that we produce. We've done probably one of the hardest decisions that we made around in Windows was for Windows Server 03. We decided from a security perspective that we needed to stop the bus for a minute and go back and look at where we were. This is before the product shipped. And we essentially took all the developers and said, Friday, you're stopping. And for the next 2 months, we're going to do a bunch of security training on every developer and tester and program manager. And then we're going to come back and we're going to read every single line of code. Somebody, both the developer and somebody else, is going to read every single line of code in Windows. And so we lost probably 2 to 3 months of the schedule to be able to do that. In some cases, there were some people who got angry at us about that because they were expecting the product on a particular date and we were late. So I believe that that was the right decision to take. We realized that there were some things that we had to do, and sort of stopped the bus, did the work, and then started up again. And we will continue to make those sorts of commitments around this area sort of continually. At this point, we now have a senior VP, John Devon, who used to run all of Office previously, and he is responsible for our own engineering excellence program that we've put in place. What's very funny about this is about Microsoft getting processed. It's about Microsoft understanding development methodologies. Because really our development methodology was ad hoc, developed over time. It sort of changed culturally. And we're taking a very formal approach now to engineering excellence in our own development work and setting up sort of standard processes, procedures, metrics. We have tons of databases where we track all of the various aspects of development. Another fundamental area is around manageability. And it's manageability from the point of the architecture of the application through the development, the deployment, problems, issue tracking, through that whole life cycle are areas that we're going to address. And it's addressing it around our own technology, for instance, in the way we handle patch management, but it's management about the way you guys develop and deploy. And then the final area where we will continue to work is in that of tools and languages, and the interesting work we've done in tools and languages and work that we've done in the CLR. And I've got some interesting metrics that I'll show you as we go through. And then finally, there's 3 technology waves that we're in right now. If you go back and think about technology waves that Microsoft had, the last time we had a huge synchronous wave was Windows 95 and Office 95. Then at that point, there was this whole idea of simultaneously shipping a family of products, a wave of products at one point in time. That was the last time we did the synchronous. There have been lots of wavelets, I guess, that have occurred between now and then with Windows 84, Windows XP, Office XP, the products that you've got today. But that was the last time there was really a synchronous wave. And it's an interesting dilemma if you think about what it takes to get synchronized delivery of products that are codependent on one another. So Longhorn and then Office for Longhorn shipping at the same time is incredible activity, which essentially is around the coordination of 15,000 developers to deliver on the same day and dealing with all the impacts and cross impacts not only within their own little domains but across the whole domain of the company. And so the wave of products that you have today is really the XP Server 03 wave, and the version of Visual Studio is the Everett version, code names that we'll use there. The next big wave is Yukon, which is the SQL Server release, the next SQL Server release. Together with that is some additional eBiz product called Jupyter, which is in the BizTalk family, and a next iteration of Visual Studio called Whidbey. There are some big fundamental changes that are happening in Yukon. The first one is the CLR, the language runtime, becomes a native part of SQL Server. In other words, inside of the database, you can now write any common language runtime application. Instead of having to write triggers in T-SQL, you could write a trigger in C#. You could write it in VB.NET. Any of the .NET languages will now run inside of the database context. That's probably the biggest fundamental change that's happening there. We'll go through some of this. And then the longer term, which is Longhorn and all the various parts of Longhorn. We'll spend some time on that. And so the new wave picture kind of looks like this. You've got the seamless computing. You've then got this Yukon wave, which is going to go into, it's in beta 1 and there'll be a beta 2 soon. And then the Longhorn wave. And the Longhorn wave is a little bit out. And as you saw in that earlier video, Longhorn is going to change a lot of the fundamentals about the way applications are delivered. The sort of Longhorn catchphrase, I took this from the Longhorn internal website, and I'll read it to you. I'm not sure you can see it. It says, the Longhorn client is the beginning of a product and technology wave that will define the digital decade. So we believe that Longhorn is going to be one of these big fundamental changes, not only in the operating system and what the operating system provides, but in all the applications and servers and services that come available inside of that wave. What is a digital decade? What do we think a digital decade is? So we've done a ton of work going back and looking at data, at information, looking at what people have on their machines, how they interact with one another, and also dealing with your persona at work and your persona at home, and how you as an individual have these multiple roles or multiple personas, but they cross over with one another. And purchasing at home, should that be any different about purchasing at work? Are they the same application? Are they different applications? The fundamental things that you're doing as you do that purchasing are the same. You're selecting from a catalog and you're deciding what you want, you're deciding how it's going to be shipped, and then you're deciding on the payment mechanism. Also, the people that you interact with are fairly similar. We as individuals interact with various governments, local, state, federal governments constantly. We're actually communicating with these people all the time, not in a different way than businesses do. Maybe the volume is different, but we continue to have these very interesting interactions with government that we don't really think about. The same is true of education. And so we're thinking a lot about the data, the information that's involved in this decade, as well as the interactions. And there's a fundamental part that comes out of this, which is process flow. It's the way applications are built is a sequence of things that happen that operate on the data. And so we're spending a lot of time thinking about how you build those individual services, and then the composition model around them, how you start to aggregate those services together to form an application. And so going back to the architectural slide about stability, we believe that the things that you do are stable. The way you aggregate them together has a very short half-life because it changes. Processes change. Plus, processes are customized to the individual. And so we see processes changing dramatically as you deal with different companies. And so I'm a great fan of trying to establish standard schema for document structures. I'm much less of a fan about trying to establish industry standards for processes. I think that it'll take us to an interesting point, but it'll go beyond the place that we need to be, because I believe that as companies start to interact with each other and as individuals start to react with each other and with businesses, that those processes will be customizable. And it's back to my example, of Costco and Walmart, and me as this little company trying to deal with them, because both of them have established their own standards. And so I believe that the world is going to continue in that way, and that the point of investment is around the individual elements of what we do, not on the composition of those elements. That means there's an interesting requirement back to us to provide a composition engine, tools, customization of those tools that will allow an end user potentially to change the composition model in a way that's interesting to them within the policy that they've got. So you start to see policy come in about, if you're participating in the process, I give you the rights to do certain things in the process, but not other things in the process. So the management of that policy is going to be pretty interesting. The sort of framework that we established for this is this pretty picture called the Windows Server System, which is sort of the aggregation, the big picture that has all the pieces. So it has the Windows Server at the bottom, all the various pieces of the Windows Server, and then the top pillars are the various pillars of investment for us in the way that those are shipped. And we're constantly thinking about ways to differentiate the servers from one another, but also to integrate them with one another. Because in many cases, taking two of them and putting them together starts to lead to interesting uses of the technology. And so we continually review the sort of structures of these products. Think of these products as an aggregation of technology. And we sort of have a pool of technology that we're trying to slice and dice them in different ways to package them and assemble them together. To sort of extend that, we add three pieces. The first one is Office, what's called the Office system, which is all the various aspects of Office, business solutions, our applications pitch, and then Visual Studio as a spine. One of the very interesting products that came out with Office 03 is the ability in OneNote to deal with XML and XML documents, and how you can start to play with XML documents and the composition of XML documents. It's been fascinating to us to watch how people have been working with that and adapting with that particular product, and starting to change some of our thinking about the integration of XML into the client-side application. It's been really a learning experience for us to see how people are starting to use those particular products in interesting ways. But there's an important part of the server product, the family, is around the integration platform. And so it's not just about our products and how our products work with one another, but it's how our products work with the installed base of systems that you have, both ours and others, either in industry standards or in proprietary ways. And the work that we've been doing with the various technology partners, all of us, all the vendors are really aggregating towards this web services integration model as being the common way of doing this. This web services integration model does not address the hard work of the connectors. If you have an SAP system, you have to build a connector, an XML connector into SAP. That's actually relatively easy to do if you've tried that with SAP. But across various systems, it gets harder and harder. And when you go talk to state and government, enterprises that have, a healthcare system in a particular state that's written in COBOL, they don't even have the source code in some cases to be able to map connectors. And so building those connectors is hard. We have some technology to help, but there's work to be done for all of us that allows these various older systems to be able to integrate into this model. There is, however, the common agreement amongst the technology providers that web services is the way we're all going to focus to achieve that integration. And so you'll see many of us start to produce our own sets of services so that you don't have to do the connectors, but that we as technology providers and as application providers will provide that connector architecture. And so the Longhorn view, you'll start to see various variants of this picture. I'm not going to drill into the various objects and their APIs, but this is sort of the high-level view of what Longhorn looks like. The simpler view is actually easy to understand. There's really work that we're doing on the fundamentals about what an operating system is and how we should make it better. And then three areas of investment, which is around communications and around data, and then around presentation. There's one big change that we are introducing, which is this thing called OneFX, which is the new API set. It's the new managed API set that we're introducing with Longhorn. That really is one of the discontinuities that you guys need to look at and understand what impact it has on you. We'll come back to that. And so for the rest of the presentation, I'm going to use this as a little bit of an outline to try and talk about the agenda and where we are in the agenda. So first off, we're going to talk about data and information and the impact that that has over the life cycle. So we'll look at three ways. In the Yukon wave around data, I talked about some of them. Two interesting pieces. One is object spaces and reporting services. Object spaces is about an OR mapping service that we're doing, and reporting services is some value-added reporting within Yukon. And then in Longhorn, the interesting thing is OneFS, and I'll spend quite a lot of time talking about OneFS. And so many of you are using ADO.NET today. The model for ADO.NET is not going to change. You'll just get some more interesting APIs, and you also get a big performance hit. But object spaces is about an OR mapping layer. It's about an XML mapping layer. It's something that we've tried to do several times, but have not been able to do it successfully internally. But we do have a structure for doing this. We do understand how to do it. Interesting enough, historically, One of the reasons that we've been able to do this time and where it works is that in our business solutions group, they're working on their next generation application set called Project Green. There's been some stuff written on it, which is the next generation business application. One of their requirements has been they deal in objects, they deal in business objects. The underlying database, however, is a relational database, and so they had a whole series of requirements around OR mapping. And this team that's working on this project has essentially taken a lot of their requirements plus things they've been hearing from you guys and sucking that in to build this OR mapping service. We will provide some templates of some core objects, some domain areas, customer or an address, but you can manipulate those and work on them however way you like. But it's just another set of very interesting class libraries that allow you to interface with the data into your applications if you want to have an object data orientation. There's still a big debate, frankly, between should the business objects be objects or should they be components? I'm not going to address that in this session, but I don't think the jury's back in yet on that one. I actually think that there are lots of ways of building applications, and different scenarios I think can be solved in different ways. The Yukon reporting service. Let me give you an example. I went to see a financial service customer on the East Coast, and they deal in lots of dynamic data, very, very active dynamic data. They're looking at trading, they're looking at their view on trading, their customers' view on trading, the market view on trading. And they had an ability for some trader to go in and create a series of ad hoc queries and generate these queries against the production BI system. And that BI system is actually growing as various trades in the market are occurring. This data warehouse is growing each day. At the end of the day, they actually throw it away and start again to the next day. They don't throw it away, but they aggregate it into a bigger warehouse. And when they went to look at the profiles of the queries, one of the things that they discovered is that everybody has issuing the same query. The query was, what's the activity of these stocks or my basket of stocks at this time of day? And they also wanted to know hourly averages, hourly activity, but they were very interested in what was happening in the previous hour and detail, not so much the earlier hours in the trading. And so what they did is they went back and built a bunch of pre-canned queries that stuffed these hourly results set into a reporting server and then pulled them up via a set of web pages. There's still the ability to generate ad hoc reports, but their customers, their users are very happy because their response time is higher, the data is very accessible, and they're not getting any performance impact back into the data warehouse because these are batch-generated reports. Kind of a step backwards in where we thought we were going, where everybody needed interactive reports. But that's not true. So this is a requirement that we have seen over and over again. So within Yukon, there's a thing called the reporting server, which is the ability to build these kinds of reports in a product-like way, build a catalog, build a way to navigate through the catalog, to look for these reports, set up a set of favorites, which are these are reports that I like to see, and find a way for end users to quickly get at report-style data without having to run a fully interactive data warehouse. And those requirements all came from customers who have built data viewing systems of various kinds in the way that their customers, their users, are looking at that information. So WinFS, let's spend a little time on this, is really going to change the way applications are built. Three fundamental tenets of WinFS, the Windows file system is what WinFS stands for, is about the way you deal with data. It's about finding information, which means you've got to understand the schemas and the queryability across the schemas. Relating your information. So if I have schema-side storage where there are common keys, I'd like to say, the contact inside of this email is the same as the contact inside of this contract. Therefore, this email may relate to this contract. And then the ability to act on that information. If you have schema-side storage, you can then have a query that runs on that storage that allows an information agent to look at the information as it's being updated and make some decisions in a programmatic way about what to do. Very simplistically, if I drag a file into a folder and the file is a 5 megabyte file, I may run an agent that says, when this folder accepts any files greater than 1 megabyte, move a copy somewhere else. Sounds a little bit like the email wizard that's inside of Outlook, where you can start to do the rules wizard and move files around, but in a much more sophisticated way because it has access to the schema of the storage. And so part of what we start to address is the aggregation of data. Right now, data, different data types, different data files, are stored in different ways. in most cases, they're big blobs. If I want to be able to query an Excel file, I have to open the file, have Excel open the file for me. That allows me to go into that file and start to look for things in that file. Wouldn't it be interesting if I had a better way of searching into various levels of content? Let's look at something like PowerPoint, just as an example. If you assume that this database looks like a set of tables, PowerPoint could be stored as a big blob. That's one way of storing a PowerPoint file into a database. I could, however, say each slide is a row in that database. And I could have a master slide or different master slides, and then a PowerPoint presentation is a query into that table of slides. The interesting for me in that scenario where I have a collection of 1,000 slides, and when I want to do a particular presentation, I just name those slides by index, and I say these slides are in this presentation, these slides are in those. I can start to share slides in pretty interesting ways, and in my query I can superimpose different master layouts onto them depending on the query. You can take it one step further, which is every slide is actually made up of various elements. It's made up of some text, maybe some image, and some animation. So there actually are transition rules that are in the slide about the way an image flies in, the way it dissolves, it flies out, it grows, it shrinks. Each one of those could then be rows in the database. So I could have a row that is a particular image like I have over here in this slide, and there are rules about that image, which is dissolve the image into the slide in 5 seconds. And so the rules could be expressed in a rules language, the image could be stored separately, and my files start to break down in structure. To take it to an interesting extension, an MP3 playlist is actually a sequence of digital images being played without much flexibility. Playlists don't allow you to do fade in, fade out. You can either do a prescribed list or you can do a random list. And a PowerPoint presentation is actually not dissimilar. It's a sequence of images being played according to a set of rules. And so you'll start to see these various media types being aggregated together and being stored in interesting ways, and the way they get played is, in theory, being played, which is the way they appear on a screen or through a speaker or through a communication line, will be via some rule-related engine. And so when you start to think about the storage in that way, what does that mean for something like a contract? If I have a contract which I'm storing into the file system, some of the contract is structured data, some of the contract is unstructured data. Termination dates are pretty important in contracts, and I'm sure all of your companies have systems to do contract management where there are calendars set on expiries and auto-renewals. There's probably things that happen to those contracts you don't want to happen because you're not monitoring auto-renewal. You can now schematize that particular set of storage, and you can query across it, and you can act on it in pretty interesting ways. And this is going to change the way applications are going to be built. Well, one of the interesting things that we have today is that data is really trapped inside applications today. In this case, I'm just using an example of people. But across all of these applications that we provide with you today, this is not even the stuff that you have. This is the stuff that we have. There are people, there are schemas of people across all of those applications. And by the way, not all those schemas are identical, just in case you were worried. Those schemas are actually similar but different. And it's also the shell that has been the place where you've tried to tie these things together. And you as a user have had to have the ability to understand the differences between an Outlook contact and an instant message contact. Why are those different? It shouldn't be. And so what WinFS is about is taking a lot of that schematized context of the applications and moving them into the file system. Taking people in this case and moving them into a common place and then having connections, links if you want, or relationships if you think in databases, that connect the applications to the single view of data. And so one of the things about WinFS is the development of this canonical storage, this canonical schema, which is a schema of people, places, things, and time, and how that gets reflected back into your applications, and how extensible is it. One of the problems we have not solved is the clashing extensibility of schema. In other words, we ship a standard schema for contacts, for example. But you buy a CRM from another company, and that CRM system has a slightly different view of contacts. Let's say it's not damaging, but they actually extend the schema. And so your CRM system then extends the schema of contacts, and they provide two additional interesting parameters of the schema of person. Maybe your birth date is an example that's something that a CRM, or your golf handicap is something that a CRM system would get. But then if I get another application that uses the same people schema and I start to get into clashes, I get into namespace clashes. And so the things that we haven't worked out, that we're still trying to work out, which is more of a policy-related issue than a technology issue, is how do you deal in the schematization of keeping schemas independent? And are those schemas just views, or do you actually have private schema and public schema? We're trying to deal with some of those issues today. So what are the things that you can start to do in this content addressable schema? So the first thing is explicit relationship through containment. Folders. Folders contain things. Digital pictures is an interesting example in this. I'm sure many of you now have digital cameras. It's amazing the growth of cameras. The people who are profiting most from that are the disk drive manufacturers, because we all go out and take many bad pictures that we don't throw away and just suck them into our computers. And those pictures have fascinating names. The names are like MVC012S, MV3034S. They have no context to the name. If you're disciplined, and I'm sure you all are, once you've loaded your pictures in, you go in and actually annotate those names so you know exactly where they were. These are my pictures from Hawaii. These are my pictures of my dinner party. These are this birthday party. Those are typically aggregated in folders. We give folders names, and we don't give pictures names. And so part of this is, if I have a particular picture that's in one folder and I want it to occur in another folder, today I have to make a copy of the picture. When you start to get to this containment view where a folder is just a query, back to my PowerPoint example, you can start to aggregate and get different container views of that information in interesting ways. You then get implicit relationships through queries, which is because I have similar information, I can start to query and join across information. In this case, I've got some email and some events. I spoke at an event like this. I made a contact with some people, and I receive an email. I'd like to get that in a single context. I'd like to be able to go back and say, show me all the email from the people, from these people who attended the SFA conference in Lake Tahoe. I'd like to be able to run those kinds of queries instead of having to use annotated text to do that. I want to be able to query against that in some way. The interesting question for us is, what does the ad hoc query tool look like? How do I, in the shell, provide an ability for people to sort of author those queries, save those queries? And so those queries start to get saved, potentially in things that look like folders. So if you use Outlook 2003 and you see smart folders, that's a prelude to what some of these queries will look like. And then finally, sort of explicit connections between items, because there are actually links, established links in the database between them. And so WinFS is a pretty interesting collection of schematized storage. There are interesting problems of synchronization that we're still working on. It actually turns out to be a pretty hard problem. I have one of these wonderful USB dongles, and I take some files from work and I go home and I manipulate them on home. How do I synchronize my home stuff to my work stuff? The more interesting example is, I've got Longhorn with WinFS installed at work, but I've got Windows XP at home that has NTFS as a file system. How do I take WinFS files, take them home and operate on them, and be able to bring them back in? And what's the intelligence I have to put on that dongle that allows me to do that? Hard problem, actually, to do. So synchronization of data and the transformation of data from the old world to the new world and back again is a tough issue. Computational roadmap. In Whitby, which is the next version of ASP.NET, the most interesting thing is actually that first line. We're going to reduce the number of lines of code. We're going to go reduce the number of codes by 2/3. So one of the interesting places where I get involved with customers is around the comparison between .NET as an environment and the various J2EE environments. And a place where we generally win is in the place where we start to count how much code do you write. And that's a huge focus for us, is to get you and your developers to be able to develop applications in less code. And we're very focused on that. And so this Whitby release, which is in a Yukon Wave, a big focus is in the class libraries that we ship that allow you to write less code and get this incredible performance. And so if there's anything you come away with from this slide, it's less code. A whole bunch of interesting innovations that are going to occur in Whitby. From a data perspective, It's this object spaces and the ability to deal with integrated or mapping layer. But some interesting deployment stuff around drag and drop of deployment and the ability to integrate web services through either web services directory, for example, through UDDI, back into your application. Probably the biggest impact is this thing called WinFX, which is the new API set with Longhorn. If you think of the API generations that we've had, I don't think we really thought about MS-DOS as an API set. It was more about some INT21 facilities that you could get at. The 16-bit Windows was the first time you really got the sort of integrated view of the capabilities of a system through an API. Win32, which kept on growing, it got bigger and bigger and bigger. And then WinFX, which is really a refactored way of thinking about operating system services. But WinFX is a managed code API set. It's still accessible from C and C++, but you start to get the real benefits of it in calling it from managed code and providing that managed code integration. It has some interesting markup capabilities. I'll show you what Avalon looks like to do markup. But it's built on top of the .NET framework. So if you're writing to the .NET framework today, writing to WinFX is actually just a logical extension of that and really provides you with a migration path of where you are today into this new world of WinFX. Interesting tools piece of work that we've got to do that starts to talk about this new API set and how you start to build applications that have this less lines of code in a consistent model. And so the big part of the work that's gone on here is a refactorization of the set of services provided by the operating system plus the other technologies that really is a new conceptual model of the way to call our infrastructures. And so you see a namespace map like that. There are very pretty posters that we make available today like this. At the PDC, we started to release some of this stuff, and you continue to see publications from us that start to address the namespaces, the change of the namespaces, how you migrate in the namespaces, but really the sort of fundamental rethinking of an operating system and the way it publishes its capabilities. There's a lot of work around security, which is back to this people problem, which is that you discover that people are everywhere. People are all in your applications. People are in directories. People are in far too many directories because we all have more directories than we actually need for varying reasons. Actually, just a little thing about that. When you have an Active Directory and you have an ERP system and you have an email system, they all contain lists of people. Now you've got an instant messaging system that has a list of people. You have applications that have lists of people. And so the common way of trying to understand people is hard, but then it's what can these people do? And so there's an interesting security problem about how do you deal with people and groups of people. And so one of the interesting byproducts of WinFS is the single view of people and groups. A group's just a query on a collection of people based on attributes. I participate in a group and therefore I'm attributed into that query. And so in Longhorn, people, in WinFS's implementation, land up just being a query into a common collection. And it's really going to change the way you deal with people, it's going to change the way you deal with security, and more interesting enough, the rules that are implied and imposed on top of people. So one of the interesting products that we've got out right now is this rights management product. And we've deployed that internally, and it's changed the way we send out emails internally. So if I want to send an email to somebody, and I don't want them to forward it, I don't want them to be able to copy any text from the message, and I want them to reply to me, and when they reply to me, I don't want the original message, that can all be set up as a set of digital rights management. And so when we do organizational changes, those all internally now come as DRM mail. Because that was the biggest leak to the media, for example, was that we'd do an organizational change and then somehow some media personality would get a copy of the organizational change or would see a mail about some technology change. And so we superimpose on top of that rights management that can actually be assigned to an individual, be assigned to a group, can be assigned to a company that starts to constrain just email in this case about who can read the mail. But it's even who can cut and paste from the mail. Like, I tried it, I didn't believe it. You can't cut and paste. You can't select text. You can't print it. It actually is just what you see is what you get from the screen. And that can be imposed onto documents. That can be imposed onto contracts, onto letters. And so long as you have the infrastructure in place with your trading partners you can send a contract to your trading partner because the DRM business rules travel with the document. They, for example, can't change it. They may not be able to print it. And by the way, that document could blow up in 3 days. So let's say you have an offer to buy a house that has an expiry on next Tuesday at noon. Next Tuesday at noon, the document evaporates. All they can see is that the document exists, but they can't even open it beyond that date. And so it starts to put some very interesting structure in rights management, not around digital media, which is how much of this came about, which is how you can buy a song over the internet and actually not copy it, but really in the dealing, how we deal with business information, either internally in the organization or across organizational boundaries. And so this whole idea of distributed security and federated security is really going to change a lot of the ways around the way we think about them. These slides are in a slightly different order to the one in your deck. When I was reviewing them on the plane, it didn't make some sense the way you had them. So the interesting thing that's occurred in the Windows CE area has been the rate of change that's occurred in CE. Essentially, there's an annual release of that product, and it actually comes in multiple manifestations. It comes in PDAs, it comes in cell phones, it comes in RFID scanners. It's very interesting places where we're starting to see Windows CE occur. One of the reasons that we're starting to see that is because the programming model is consistent. The programming model is the same. If you're going to write to the Compact framework, the Compact.NET framework, it's the same tools, user experience as if you're developing to the .NET framework on your machine. In fact, there's an emulator that you can run locally, so you can develop the app locally on a workstation, debug it to the point you can, and then download it to the device and debug it on the device. And so there's a huge amount of work that's being done around the consistency and extensibility of those models. And important work that's being done in the tools, just to make it easier and simpler to develop applications. I don't know how many of you have tracked the Mars rovers and what went wrong with the software on the Mars rover, but it's pretty interesting. It's an embedded system, and the software problem was a deadlock. It actually was just a simple resource deadlock. There was a low priority task that was grabbing hold of a resource. A high priority task was coming in that wanted that same resource, but because the low priority task had it, the high priority task couldn't get it. It was not reproducible here in the labs here because the sensors on this little rover on Mars is getting overloaded with information. And so there's lots of input data coming into the sensors that's causing a different pattern of interrupts than it's causing to happen here. And so it's just a good old-fashioned deadlock that's happening there that's not reproducible here. They've managed to curtail it by actually constraining the amount of sensor information that's coming in. As soon as they've done that, the interrupt pattern has changed, and these little rovers are running around the planet drilling holes. But I still find that amazing how, there's a CPU out there drilling holes. But fundamentally, there's a lot of interesting work that's already being done to try and do the analysis of these deadlocks and why they happen. And some of them are actually just programming model, software methodology things. So as we start to get into the development of these distributed applications with incredible functionality running at the edge, the sort of development methodology is going to become a key part of how we successfully write and deploy those applications. My favorite acronym, NGSCBFW, the Next Generation Secure Computing Base for Windows. The easiest way to think about this is it's a sandbox for secure applications. It's very restrictive on what you can do in the sandbox. You actually are given potentially rights, authorization to write to a disk drive. If you don't have the rights to even write to a disk drive, you'll be blocked from doing that. And so we think that there's going to be a small set of applications that are going to run inside of the sandbox, and potentially some of the critical parts of your application will run inside the sandbox and talk to applications that are outside of the sandbox. This work is just evolving. There is some prerequisite work on some new hardware that Intel is developing that is going to change the way we start to write applications. The first thing that's going to have is secure memory management. In other words, when you do a malloc and you get a block of memory, you can say this is read-only memory, and so even if you have a buffer overflow, nobody can write into the memory. Turns out you can't get a buffer overflow because that's managed in the hardware, because when you get the memory, if you get 4K, you only get 4K, and you can't go anywhere beyond that. So there are some things from a security perspective that's being done natively in the hardware that's going to change the way we think about applications. Communications. I want to get to Indigo. Web services architecture. This is around what we call GXA, the global XML architecture. This is a set of initiatives that really started off with UDDI in the work that we did with IBM and others to start to build a set of XML services to really raise the high water of the way we as an industry work together. UDDI actually started off as an incubation with myself and another guy in my group and some people from IBM and Ariba trying to think about what does it mean in a web services world. What are some of the core things that you need to be successful? And one of the first things that pops up is you need a directory. And that's really led to a very complete set of work that we've been doing through the web services organizations, WSI and others, to start to build a common set of standards for these implementations. I mean, we'll compete on implementation. We'll have the best, fastest, most reliable, most secure implementation, but they will be able to interoperate clearly with the equivalent implementations from the other vendors. This is probably the most interesting collaborative work that's been done in the industry in many, many, many years, where we've all realized that if we can jointly work together to change the way these systems are built, it's actually for the good of all of you as customers and for us as technology companies to move forward. And so Indigo, which is really the focus of communications inside of Longhorn, is really a different programming model around web services integration. To write to SOAP web services today and WSDL requires a lot of work. There's actually it's a low-level set of interfaces that you have to write. Indigo is a very complete set of services. I think today we've actually talked about 28 different services that sits on top of the base level plumbing that provides a very rich set of services around context management, security management, reliable transactions, reliable delivery, dynamic routing. The router inside of Indigo is just incredibly fast, and that's where workflow will actually hook into the router. The router is actually just a decision maker. It gets the message in, it does some content stripping in the message, says, oh, you're meant for such and such, and then routes the message to another location. Workflow is actually not different. Workflow message comes in, you look at it, you run a set of complex business rules as opposed to some simple routing rules, and then decide the message needs to go somewhere else. And so all of that routing will start to be integrated in one. And if you go through the Longhorn documents, you'll start to see some of the object models that exist around Indigo. And on the interesting side, some of the declarative capabilities. One of the interesting results you see is a very well-structured and architected peer-to-peer environment that's enabled through Indigo. Indigo can do simple point-to-point, but you can start to do what they call peer channels and peer groups through a protocol that allows you to start to have peer groups participating in a common context, not just an application, but a common context. And so part of the work around GXA has been the development of these protocols. In this case, it's PNRP, but it's the publication of these protocols around how these various web services start to interact with one another. And the protocol set is moving way up the stack into level 6 and 7 of the OSI stack. Real-time collaboration, I'm going to skip. You can read that. I want to talk about presentation in Avalon. Here are the challenges around writing applications today. As we all start to architect and write applications, there's this huge dilemma about writing an application in the window and all the good things you get about writing an application in the window, or running in a browser and the interesting things you get in a browser about the back button. What does the back button mean inside an application? And one of the things that many of our users forget is if they're inside of an application in the browser, they press the back button and think they're going to go backwards in the application. They don't. They move backwards in the web page. And so there are things that they've done inside the application that moving back doesn't undo. If you've updated some data, hitting the back button doesn't undo that data. And so there are some conceptual model problems that exist in all of these areas. And so Avalon, which is this new UI model, is a place where we've thought a lot about providing a single model that gets the best of both worlds. It gets the best of the web world, the deployment, flowable layout is interesting. You know, when you build Windows applications, you have to assume a particular screen size. You have to assume a particular screen layout. And if people have smaller screens, then they're scrolling your application around. But the way that's flowable layout, I resize my window, and you just get this sort of very natural flow of the images and the text. On the website, you also have this declarative model, which you don't really have on the application side. However, on the application Windows side, you get the sort of unrestricted capability. It's just code. You can write it. It takes time. It takes testing. Has fairly interesting offline support because the app's still there. You get lots of different languages you can use. And so how do we meld these two together? I'm not going to talk about navigation. I want to get to this picture, which is what does an Avalon application look like? And so the user model, you saw this in some of the video when we started, when you saw some video clips of the Longhorn shell and the way that's going to look. And so we think that applications are going to start to look very differently. They actually will start to see different application models. One of the big focus for the work that we're doing right now are focus groups around the way UI is presented. And so a travel application will start to be presented like this, where you start to see I'm creating a trip and you can see my itinerary being built on the side. In today's application, that might have been done in tabs, for example, or it might have been done in multiple pages of the application. I could get a different model of an application. I don't know if you can see the details, but this is actually a legal application from a particular lawyer who's dealing with arguments in the application that he's going to make or that the opposition is making, a particular set of evidence around this particular problem, and then people, and then that frame below is actually a display of each one of the documents, the people, and the time frame. So we'll start to see a much more graphical, interesting view of the application. And so just, why is this stuff happening in Avalon when it couldn't happen before? And the real reason for that is the change of the hardware. The Windows model that we're working with today, and that's in the browser or in Windows itself, is basically the same UI model that came with the first version of Windows that assumed that you had a VGA adapter in your machine. We now just have bigger, faster VGA adapters that can do a little bit of acceleration, but the shell and the applications that we build outside of games are not built to take advantage of the capabilities that are there in those display adapters. And so Avalon assumes that you have a graphics adapter in your machine that actually has some capability. It assumes you have, ATI or NVIDIA or any of these others that have incredible processing capability, and why don't we take use of that stuff? Because today, it's just drawing Windows in a faster fashion. They'll do things like play video and audio quicker, but there's a different way of building the applications because of that computational power. And so one of the prerequisites for Longhorn is going to be a graphics adapter. There will be a down-level compatibility. If you run it on an older machine, you'll still get the same kind of user interface, but we'll pull out much of the functionality. It will be 100% compatible, but it won't necessarily feel the same, where modern applications will actually have a very different feel to them. If you think about Longhorn, though, if Longhorn is available in, let's just say, 2 years' time, then the hardware that's available for Longhorn in that window, you have to assume today's hardware for that window. And so a lot of the graphics adapters we have today are really underutilized in the commercial environment. And that's the target, is to actually unleash the power of those graphics adapters. Avalon has a programming language, which is an XML declarative language called XAML, X-A-M-L. I guess it's the same X that's in Xlang, but it's pronounced as a Z over here and an X over there. XAML allows you declaratively to start to talk about UI objects as a markup language, and so you can define a button in XAML, but you can actually use any language equivalently to write that button. You can write it in C#, you can write it in VB.NET. They're all about the same. It actually is a preference about the way you like to write your application, or in fact you might have different people doing the user interface layout than you will having the base application code. So the UI guys might write in XAML and XAML authoring tools, and the application might be written in C#. Let's look at the operational side. Some interesting thing happening on deployment in the operational view. The biggest part of that is called the SDM, the System Definition Model, which is the schematization of applications and their execution. And so the first thing you do under SDM is you create a definition of a system, either a new system or an existing system. through a bunch of tools, you identify some policies, some resources, and out of that comes an SCM document, which is an XML document. It's pretty portable. You can move it around. You can export it. But that document is a definition of the application environment. That document is then imported into a runtime environment and provides a model, a runtime model, of the environment that's then deployable to the executing capabilities. And then, if I have a model and an executing system underneath it, I can now build some very interesting tools that run on top of that model that deal with operations, deal with management, deal with deployment, redeployment, rescaling, and so on. But I have to have that model. I have to have this base schema of what's there. So as architects, what would those sort of steps look like? I'm sure you've seen pictures like this, which is, in this case, a layout of a e-commerce system that has both shopping and CRM. Those dotted lines represent, this is logical functionality, and those dotted lines represent the DMZ and available inside of my network and so on. Wouldn't it be nice if we had a tool that looked like this, that actually allowed you to draw that same picture and describe the logical components of the system that you have? You then start to take out Visio probably and talk about the physical layout of your data center, the machines that you've got, the firewalls, the characteristics of those machines. And then, wouldn't it be nice to be able to integrate that into a tool equivalently as well and start to build this common model? And so SCM is about the structure, the multiple planes of this information. Keith Short is doing a session later in the week that actually drills down to this in lots and lots of details. I encourage you to think about the models of your systems and the way they're put together, the models of your operational system and the models of your application. Having a schema for that actually releases a whole bunch of things that we can now do with it. But there is no schema for today. It's just sort of the physical stuff that happens. And then finally, I just want to deal with security. This is, you guys can read this stuff. Patch management is something that we're going to change. And patch management is really about two things. It's about the way we patch applications, and it's about the way you patch applications internally. Today it's handled via multiple channels. No, you have to go to Office Update, but not Windows Update if you're updating Office. It's a little weird. That's all going to be integrated into Microsoft Update, obviously. Within this calendar year, you'll see that. And then you'll also see the aggregation of the downstream side into System Center, which is a working name, for the distribution product that we'll have that it allows you to do this patch management and distribution. We'll also start to open up the Watson tool, the tool that does the reporting that you've seen, and open that up so that all of you can actually use that internally within your own applications. You can start to manage your own applications as you start to get failures in your own apps. And of course, we're going to dog through that. Managing identities, we talked about that. Federated security is a big one. And the issue for federated security is actually, as we start to get into extended value chains and how those value chains cross organizational boundaries, how do I establish security not only inside of my own company, but how do I establish credentials across various suppliers? And the only way to do that we know of is using some federated security, and in many cases a DRM-like structure, to be able to do that. This involves both implementations on our part and some standards work that needs to be done between us and the other vendors. It's an area that we all need to work on in the ability to start to agree on these federated standards so that when I send you a purchase order, you can actually understand who I am, that I'm allowed to send a purchase order that's greater than $1,000, and what are the interactions around that purchase order. And so there are lots of questions that I think you guys need to work on and we need to work on around the requirements for this. We do know fundamentally that we need to have a way of having different security systems deal with one another. And so to start to summarize, 5 interesting pieces. Indigo is going to deliver this infrastructure that's going to allow us to take advantages of what we are and where we're going to go and this power at the edge. Big part of what Indigo is. Pat Helen is doing a keynote, I believe, at the end of the day today that's going to start to talk about the sort of deeper environment about what that means for applications. So I encourage you to go to that session as well. Avalon's going to change the UI. OneFS, I think, is going to change the way we write applications. It's actually going to cause us to think deeply about the information in our applications and how that information is acted on, integrated, accessed, changed, and viewed. And then this deployment model is really around establishing a schema for your operating systems and where they are. And so the sort of blanket view of all of this is the schematization of what we've done. It's establishing models, and they could be relational models or XML models or hierarchical models, but it's establishing models of the various pieces of technology that we ship and that you and your applications plug into. We think that there's going to be this fundamental shift to services-oriented architectures, from function-oriented to process-oriented, from prolonged development to this really incremental development on a services base. We think that applications are going to go from application silos into orchestrated process-based applications. They're going to move from object-oriented to message-oriented and component-oriented. That's a big debate. I'm glad to have that debate, but that's fundamentally the way I think applications are going to manifest themselves, is in these capability-based components that could be aggregated as objects, but that the sort of aggregation view is going to be the component-based view. There's going to be some changes that are going to happen. There's going to be winners and losers, both from a business perspective and from a technology perspective. There are companies today that are taking advantage of the shift of technology. Paul Newman's Own, his little company is an interesting one that actually is operating as a completely virtual company. They have 17 people in the company based in Connecticut, and they do about $190 million a year selling salad dressing and popcorn, and they're incredibly profitable. All of their profit goes to charity, which is the company's successful for that. But they've thought about interesting ways of structuring, a grocery-based company that's very different from the other companies that are out there. There's also going to be this view to self-service and the impact that that has on the applications that we want to do. We do think that there's going to be this fundamental change about computers becoming much more central to the way we work. And my boss, David Vaskovich, talks about the next decade as sort of the golden age of computing, which is really with a point in time where the growth of technology has gone to the point where we can start to take advantage of it in interesting ways. And so really what this is about is riding the next wave. And as people who watch Microsoft and who develop and partner with us, it's just important to watch those waves, to look at those waves, and to see what we're doing and where we're investing, and also how it changes. Probably the single biggest change in our behavior has been in this community involvement that we show at the bottom. We actually, we used to know how to do this, and then for some reason we forgot how to do it. And so this event is actually, and all of the strategic architect forums that go on around the world, is really our step in trying to aggregate and communicate with you as a community. And through the sessions, the working sessions that you'll have through the rest of the session, listen to you and try and understand what your issues are, where you're concerned, where are we failing, where are we being successful, and what do we have to do about it. And that's what the rest of this week is about. And so, do we have any time for questions? Okay, we've got a short amount of time for questions. I know there's a lot of content and it's fairly dense. Go back to your presentations, but if there's any questions, we've got some time to handle that. I believe there's a microphone in the center, or I'll repeat them. I cannot see. No questions? It was all? Yeah.
My name is Owen Williams from SAIC.
Mm-hmm.
Is the system definition model Microsoft's version of people, or what technology is related to this process?
Okay, so the question is around the SDM, the system definition model, and what is the extent of the model, and how far and how broad does it go? So SDM is actually about roles in the application. It's around the physical machines, their relationship to one another, the logical view of the business capabilities implemented on those machines, and then it's going to get into the process flow. BPEL, which is a sort of standard today around process flow, is actually more around an integration flow than a process flow that you would see in today's applications. It's actually much more around integration, about EAI processes, than it is around an order life cycle. And so the BPL work needs to be extended so that it can deal with people in the process, exceptions in the process, forking in the process, dynamic changes of the process. And so think of BPL as a core, and as is Xlang, of what that is, but it really needs to go much further beyond the sort of limited EAI view that it has today. All right? Well, thank you very much. Enjoy the rest of the session. Enjoy the sunshine.